Alright, so now in this video, we have a zener diode here. I know it's far away. We're going to zoom in a little bit. But we're going to measure voltage here. The best way to get a reference voltage with the zener diode, even as the supply voltage changes a lot, is to use a current source. So we're going to use a current regulating diode for this video. And this is a 5.1 volt zener diode. I looked at it more closely under the loop, and it said 5.1. There you can see we got 5.062, so slightly less than 1 volt. And there's about 7 volts at the supply, as you can see right there. So we also have it where the limit current, if we get above 20 milliamps current, it won't let it go higher than 20 milliamps. Okay, so I just changed that to 20 volts right now. So we have basically 3 times, just slightly less than 3 times the voltage at the board right now. So if we were using a resistor to limit current, we would have, somewhere around like 3 times as much current going through the zener diode, and its voltage would go up. It'd still be somewhat close to 5.1, but it would be probably a bit higher. And here you can see we're still at 5.06. Now, we have current limited because this is a 1 milliamp current regulating diode. So I'm going to put this to milliamps. We're going to short across the zener diode and see that at 20 volts, and it's going to get warmer now, we actually have 1 milliamp of current. That's interesting. And recent video I didn't raise the voltage this high, but let's go back to 7 volts. When we were at 7 volts, I bet this is going to say 0.88, or maybe it's the other current regulating diode. Yeah, I think that's what it is. I grabbed the other current regulating diode. I have 2. So we actually have a really good 1 milliamp of current going through here, and hopefully you're not finding this board. I'm going to pop the other one into the board, and if this takes too long, I will edit it down. So let's see what the results are with this one. They do have a tolerance. They don't have an exact, so I'm still at milliamps of current, and there we got that. As I said before, 0.88. And now we're going to measure voltage again. So the supply voltage is 7 volts. And yeah, now you can see it's slightly less right there, because we have slightly less current. So the current will change it a little bit. Let's see if it holds steady right there. If we go to 20 volts. And again, we can go to 20 volts because the diode here drops about 5 volts, and then that's only letting about 1 milliamp of current flow anyways, and approximately. And there, yeah, you can see it's still slightly less, because we got slightly less current going through. But since it is a current source that sets the current, the voltage will be steady at that point. So if we need a steady, in this case, we would get 5.057 volts, 5.06 basically. If we need a steady 5.6 volts. This setup will provide that even as the supply voltage is bouncing around. So now we have the diagram here. This is the schematic symbol for the current regulating diode, or current limiting diode, whichever you want to call it. So there is a cathode right there, and then an anode over there. We'll look at that a little more over there. But it's setting the current through a zener diode, and we were measuring the voltage with the multimeter. So it wasn't drawing current, just a very small trickle was going through. Generally, if you want a steady reference voltage, you just set that voltage and you have something else look at that voltage and respond to it. In the case of the multimeter, it displayed the voltage on the display. That's all it did with it. It didn't draw any current to do anything. So you want to hold that voltage as steady as possible. If it needs to be steady, by giving it a current source. So this is not a current source symbol. That would be a circle with an arrow in it, and then like 1 milliamp next to it, or 0.001 amp next to it would let you know the amount of current that is flowing, and thus will be flowing through the zener diode, which is reverse bias. You got to get it wired reverse bias to get the zener voltage right there. So again, there's the symbol. As I said before, over there is the anode. Over there is the cathode, either called current limiting diode. You might see it abbreviated as CLD, or current regulating diode. You might see it abbreviated as CRD. And I wrote right there constant current diode for some reason. Maybe some people call it that. But in any case, this is the part number. Again, you don't need to buy a current source component. In this case, S102. I got it out of the Joe Knows Electronic Semiconductor Kit. I'll put the link down below. But in any case, I just got it out of the kit. I believe in getting these semiconductor components after you have the basic components, because there's a lot of cool ones there to learn about. So the S means that it is a surface mount component. So it is this little rectangle right there. The rest of this board is just to support it. There's traces going over these pins. I don't think that middle one's connected to anything. But in any case, that's the cathode side. It comes there. And so I put the cathode because we forward bias this one. And if we put it in backwards, it should block all current, I believe. I don't think I've tested that out. But we're getting it to get current through the zener diode. So it's building up about 5 volts across it. When I had the power supply to 20 volts, that means there was about 15 volts that built up across here. So you multiply that by 0.001 amps of current flowing through it for the wattage, and it's a very low wattage. That would be less than 0.01, I believe, watts. And it can handle a lot more than that. So in any case, we're not going to worry about that. So the 102, that means 1 milliamp. So that's 1 0 and then 2 more zeros. So you can see 1 0 and then 2 more zeros. That's in microamps though. So 1,000 microamps is the same as 1 milliamp. And the data sheet, there's basically a tolerance. It says it might be as low as 0.88, which one of mine was, and it may be as high as 1.3 milliamps. But the other one that I had looks like it was pretty much 1 milliamp spot on, like 0.99 milliamps. And so yeah, if the number said 301, you saw the same component, but it said 301 instead of 102, then that would be a 3, and then a 0, and then one more 0 after that, which would be 300 microamps, or 0.3 microamps. And again, S series is the surface mount. The E series should be, I don't remember if they look like this type of diode or not, but it's got 2 wires, like this zener diode, if it's the E series. I can't remember if it looked more like a resistor or more like a regular diode, but it's a 2-wire component, 2-leaded component. Anyways, if it is E series right there. And it has an allowable reversed current. I can't remember why that is important. I'm not trying to use it reverse, so but I wrote it down there for some reason. I made this a long time ago. So in any case, that is about it. Again, you don't need one of these particular components. There's a number of different ways to get a set current, if that is very important. And it may involve using another zener diode to get a steady current. But in any case, this is one of the options. And if you have this kit, you could make this practice circuit and other practice circuits where you need about 1 milliamp of steady current even as the supply voltage is changing. If the supply voltage is really steady, then a resistor will hold a steady current. But if it's bouncing around, then the resistor will be changing its current. It'll be thrown off. So in any case, this is a long video. I hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.